Today we're going to talk about biconditional statements. So we are going to use what we have learned in previous days about writing a conditional statement and a converse and what happens when we can kind of put them together. So a biconditional statement is when and the converse are both true. And the way we say that is if and only if. So it means we can do P then Q, but it also works in reverse. So we use a double arrow. So if P then Q and if Q then P. It works the same way. So for example, collinear points are points that lie on the same line. The conditional is if you have collinear points, then you have points that lie on the same line, and that's true. If we write the converse, if you have points that lie on the same line, then you have collinear points. That's also true. So we can write a special statement called a biconditional, and we leave off the usual if and then, and in the middle we put the phrase if and only if. So a biconditional is written as you have collinear points if and only if you have points that lie on the same line. So we're going to try two examples. So for each of the following statements, we're going to assume that the conditional and the converse are both true. So we're going to write the conditional, the converse, and a biconditional statement for each. And the reason we write biconditionals is because most often these are used to write really good definitions. So a biconditional is a little bit more strict than just a regular conditional statement. So a scaling triangle is a triangle with no congruent sides. So we start off by assuming we have a scaling triangle. So if a triangle is scalene, then it has no congruent sides. The converse is if a triangle has no congruent sides, then it is scalene. Notice we always want in the hypothesis to make sure we are really specific as to what we're talking about. So don't use words like they or it in the hypothesis. For the biconditional, again, we start out with the original hypothesis. So is scalene. So notice we no longer start with the word if. Okay? This triangle is scalene if and only if it has no congruent sides. So you can see these are a little bit more strict. If and only if implies that there's a very strict condition for something to be true. Let's look at number 2. A 6-sided polygon is a hexagon. So there's a couple ways you could write the conditional so that it makes sense. So I'm going to write it like this. If a polygon has 6 sides, then it is a hexagon. The converse, if a polygon is a hexagon, then it has 6 sides. So as the biconditional, a polygon has 6 sides if and only if it is a hexagon. So you take a moment to try number 3 on your own. So here's your answer to number 3. So the conditional, if angles are complementary, then they have a sum of 90 degrees. The converse, if angles have a sum of 90 degrees, then they are complementary. And the biconditional, angles are complementary if and only if they have a sum of 90 degrees. Now let's look at what happens if you're not sure if you should write a biconditional. So we want to write a conditional statement, the converse, and decide if they're true or false. If they are both true, we can write a biconditional. If one of them is false, then we will show a counterexample. So our first example, a giraffe is an animal with a long neck. So if an animal is a giraffe, then it has a long neck. And if you've ever seen a giraffe, you know that's true. But let's switch that around. If an animal has a long neck, then it is a giraffe. If you think about that for just a minute, I think you can probably come up with some other animals that have long necks. So this is false. So since one is true and one is false, we don't write a biconditional, we're going to write a counterexample. So one example that comes to mind for me is a flamingo has a long neck. So we can't write a biconditional, but we can give a counterexample for why we said the converse was false. So for number 5, you are a twin, making you a sibling. So if you are a twin, then you are a sibling. And that's true, because if you're a twin, you'd have a brother or sister identical to you. The converse, if you are a sibling, then you are a twin. Now, I have siblings, but I'm not a twin. So this is false. You might be the older or the younger. Okay. Number 6. If two lines form a right angle, they are perpendicular. We don't have to change too much here. If two lines form a right angle, then they are perpendicular. That is true. So the converse, if two lines are perpendicular, then they form a right angle. That's actually the definition. That is true. So here, we don't need a counterexample, we need the biconditional. So two lines form a right angle if and only if they are perpendicular. So you go ahead and try number 7 on your own. So there's your possible answer to number 7. And that is the notes on biconditionals.